Hey everyone, welcome back. Today we are talking about factoring binomials. So this is going to be the first time that we really start looking at a polynomial. This time we're going to start with binomials, so just two terms, and we're going to look at pulling that greatest common factor out and then what remains afterwards. So how do we do that without changing the value of the expression or equation as well? And after that we'll look at factoring by groupings. This is another method of factoring. Same strategy, one extra step. Questions for today: what do you do once you've identified the GCF, and how do you rewrite it in factored form? And then how do you check your answer for accuracy? Okay, so if we're asked to write a polynomial in factored form, it means that so factors are, again, numbers or values that multiply to be an original item. So when we think like the factors of 6, we think of 1 and 6. So I multiply the two of those, I get 6, or 2 and 3. So factored form would be like the factored form of 6 would be 2 times 3. So I've broken it up into its factors, and the factors are multiplied, which is the same as the original value. So if we've got the polynomial 3x plus 12x squared equals y, and I want to rewrite this in factored form, I would first have to look at it and be like, okay, two terms, 3x and 12x squared, what is the GCF, or the greatest common factor of those two? And you would probably tell me it's 3x. So I take the 3x out. So 3x is factored out. And then I open up a parenthesis, and I have to think of what do I have to multiply 3x by to equal the original 3x. So 3x, it's already the same, which means I just have to multiply by 1. I just need it to be the same thing. Then the second term, 3x times what, is going to be 12x squared. Well, that would be 4 to get 3 times 12. 3 times 4 is 12, and then x times x is x squared, so I need a 4x. So we refer to that as the GCF is going to be on the outside, and the remaining factors are going to be on the inside. So when you do your distributive property, you should get the original equation back out again. All right, another example, I have 6ab minus 9ac. Thinking of the factors of 6, I've got 1 and 6, 2 and 3, and I've got the negative numbers too, I might as well throw them in here. And then I've got minus 9 is the other value. So I've got 1 and minus 9, 3 and negative 3, 9 and negative 1. So as I look at that list, I'm looking for the greatest common factor. So what number on this list appears on both and is the biggest? So minus 3 appears on minus 1 appears on both, and positive 1 and positive 3. So positive 3 is my greatest common factor. So I know 3 is going to come out. Looking at the letters, they both contain an a variable to the power of 1. And b and c are different in both. So a is common, so I take a out. I'm done with my GCF, so now I open up my parenthesis, and I think 3a times what is going to be 6ab? Well, I need a 2. And I need a b. 3a times what is going to be negative 9ac. So 3 times what is negative 9? It's minus 3. A times, a is already accounted for, so we got an a, so I need a c. So I can just slot that in at the end, and then I close it. So my answer is 3a times 2b minus 3c. And the way I check my answer is I do that distributive property. So 3a times 2b is 6ab. And 3a times minus 3c is minus 9ac. So it matches my original expression or equation. So I'm like, yep, we got it. All right, so I want you to try it now. So write the following equations in factored form. Make sure you're pulling out the GCF and then writing the remaining factors as well. Pause the video, come back when you're ready to see the answers. Okay, so we got 15abc plus 20ac. 15 factors, 1, 3, 5, and 15, 20, 1, 2, 4, 5, 10, and 20. So the greatest common factor is going to be 5. We have an a in both and a c in both, so I'm going to take a, c out, and that's it. 5ac times blank is 15abc. I'm missing a 3 and a b. And then 20ac, I need to multiply by 4, and the variables are already matching. I have an AC in the greatest common factor, so I'm just going to multiply by 4. For number 2, the greatest common factor between 100 and 24 is 4. So 4 times 25 and 4 times 6. X squared, remember, is x times x, so there is one copy of x in both of these. So we would say 4x is my greatest common factor, and then what's left is 25x plus 6y. For number 3, greatest common factor between 4 and minus 6 is 2. And a squared is a times a cubed, a times a times a. There's 2 a's common in both, so I'm going to make a squared my GCF. And then 2 times 2 is 4. The a squared is already there. And then we got to multiply by another 3a to get negative 6a cubed. And I'm sorry, I should be finishing off these equations. Number 4. Now there's 2 possible ways of doing this. You could say that negative 10 is a common factor to both, and you wouldn't be wrong, but technically the greatest common factor is positive 10. Nothing with the variables. So I'd have 10 times minus g, and then minus 2k equals y. So the reason I was saying minus 10 could also be a factor, like if you took minus 10 out, you would have g plus 2k equals y, which is an acceptable answer. Like there's nothing really wrong with it. So we're not always going to have to take out the greatest common factor, but we're being asked to in this case. And number 5, 56x squared yz plus 64xyz equals k. Greatest common factor between 56 and 64 is 8. And we've got an xyz common to both. So then 8 times 7 is 56, and I need another x to get that x squared back. And then plus 8 times 8 is 64, and xyz is already accounted for, so I can just close this off and put equal to k. That's it. Factoring by grouping is next, and this one is the exact same thing that we just did, except there are 4 terms, so we're going to do what we did twice plus an additional step. So grouping is just telling us that we're going to take pairs of these terms. So the first 2 and the last 2 is a good one to do, but you can technically pair these up any way that you want, but you're looking for things in common. So like 3xy and 15x, like it looks pretty good. The only issue would be that 21 and 35 don't really have anything in common, so it wouldn't make a good pairing to start with. It will still work, but it's just not a great one. Versus the first 2, 3 goes into 21 and 3, and there's a y common as well. And then for the last one, we've got a 5, which goes into 35. So doing the first 2, greatest common factor of 3xy minus 21y is 3y. And that would leave me with an x minus 7. For the second pair, so 5x minus 35, the greatest common factor is 5, so plus 5. And then I have x minus 7 again. So normally we'd be done in the last one, but in this one, we now see that there are 2 terms. So there's 2 parts to this expression separated by an addition sign. And in each of those terms, there is an x minus 7 that is common to both. So I can actually say, let's do GCF again. GCF is now x minus 7. And then what's left will be 3y plus 5. So the 3y coming from over here and the plus 5. So if I distribute this, so x times x is 3xy, x times minus 5 is 5x, minus 21y, and minus 35. It matches all of the terms in the original polynomial, so I know I've done my job right. All right, so your turn. I want you to factor by grouping. Same stuff we were just doing, just an extra step at the end. Pause the video, come back when you're ready to see the answers. Okay, so if I do my first grouping and second grouping, for the first one, 6mx minus 4m, we have a GCF of 2m, and that would leave me with a 3x minus 2. For the second one, all that's common is a 1r, so we just do plus r, and then we got 3x minus 2. If the parentheses don't match, and we'll see this in a second, but if they don't match, sometimes it means that we've made a mistake, sometimes it means that you can't do any more factoring on this one, and sometimes it means we need to do something slightly different. So, but this one matches, so we can take the 3x minus 2 as our new greatest common factor, and then 2m plus r to finish it off. For number 2, so we got 15x minus 3xy, so that's 3x is my greatest common factor, and that leaves me with a 5 minus y. And then the next one would be plus 4y minus 5. Now this one's interesting because we have 5 minus y, so the 5 is positive, the y is negative, and in the other one, the y is positive, but the 5 is negative. So this one on the surface maybe looks like, oh, we can't do anything else. But if we instead now say, well, instead of taking positive 4 out, what if I factored out negative 1 as well? So really I took out negative 4. Now I would have 3x 5 minus y minus 4, and I would have minus y plus 5, and that is the same as 5 minus y. So I can just rewrite that as 5 minus y. Addition, you can change the order, just keep the signs the same. So now they match, and I can say 5 minus y is my greatest common factor, and what's left is 3x minus 4. This is probably as hard as it will get, where the original greatest common factor is not actually what you want. You wanted a different factor that allowed this to be grouped and then factored again. So it's a puzzle, and the only way we get good at it is to practice it over and over again. So we will do lots of practice of these. You'll see some of these situations pop up, but most of them will look like question 1, where the two factors will have something that is common, and then you can pull it out. Okay, so for tonight, I'm going to give you 2 different worksheets. We're going to work on them in class tomorrow as well, so it'll be a work day. You have factor binomial expressions, and then you have factoring by grouping. You'll see both of those posted in Schoology, or you can pick up your copy in class. I'll see you soon.